Everyone, my name is Sam Parry. I'm here today to do a quick paper 2 walkthrough of the White Rose Maths predicted paper. Hopefully you find it beneficial. If you've been working through it on home, then well done. Fair play for putting in that extra work throughout half term and in your own time. Hopefully it pays off. But hopefully this walkthrough will give you a good idea of how I would go about answering some of these questions. And hopefully it gives you an idea whether you got the question right or wrong, and then some of the mistakes you may have made. And then if you are, hit a question you're completely unsure about, then hopefully my explanations and my strategies are ones that you can utilize and benefit from. But yeah, we'll see. So it's a 33-page or 33 question paper, so it might be quite a lengthy video. So get comfy, grab yourself a drink. There we go. And yeah, get set. But just a quick reminder before we get into the questions. Maths exams, there's 2 of them to go. So at the time of recording, which is the 30th of May, you've got a second paper on Tuesday, the 7th of June, so a week tomorrow. And then finally, your last paper is in 2 weeks' time on the 13th of June. So 2 more weeks of hard work, of revision, of preparation, and then your maths GCSE exam summer series will be done. So the finish line is in sight, but let's finish the year strong and put everything we've got, leave it on the table, basically, and then you can relax. Just a quick bit of advice before we work through this paper is try and answer the questions before you watch, because answering them prior gives you an idea of if you got it right or wrong, and it means that you've at least attempted it, and then you can learn from those mistakes that you may have made, or it can reinforce some of the learning and some of the answers that you've got. Now, these next 2 papers that you've got, they are calculator papers, so please try and use a calculator. Now, your phones are good, but you won't have them in the exam, so try and get your hands on a scientific calculator. These are purpose-built to help you with maths, okay? So try and get your hands on one of these. Beg, borrow, or steal if you need to. And then finally, last thing I'm going to say is make a note of anything you're struggling with. So if you're like question 14 really tripped me up, make a note of it and then contact your maths teacher and say, look, I really struggle with question 14 and 15. Is there any practice I can do, any videos you recommend, anything on Century that I can do? And then your maths teacher can support you with your revision, okay? Or if you're quite autonomous, you could even think, you know what, I really struggled with that area question. Right, I'm going to go on to Century and search for it. But I'm here to help. So if you're really struggling to get hold of anyone, contact me, Sam Parry, and I'll do my best to help you out. Okay, right, let's get stuck in. So question 1, circle the improper fraction. Now, an improper fraction is a top-heavy fraction. And what I mean by that is where the top number is bigger than the bottom one. So let's say, for example, 10 over 7. That is an improper fraction because the top number is bigger than the bottom one. So essentially what I need to look for here amongst the selection of answers is where the top number is bigger than the bottom. So there is my improper fraction. Now, some of you may have chosen this one. Now, I understand why, because it looks a bit improper, doesn't it? It's not your standard. But what it is a mixed number. It's an integer, a whole number, mixed with a fraction. So that's known as a mixed number. So an improper fraction is a top-heavy fraction like that, okay? So it's important that we know the difference. And then we have our standard proper fractions, like the 3/5 and the 6/10. Question number 2. P is greater than 3.7. So I've identified this sign to mean greater than. So P is greater. It's looking down at 3.7. So I need to identify a number that is bigger than 3.7, and that is going to give me the number 4. 4 is greater than 3.7. Question 3. Which of the points lies on the line x plus y equals 7? Now, it's important to note when you have a coordinate, like we've got in our selection of answers, we always have an x coordinate and a y coordinate. Okay, so let's say, for example, 2, 3. That means go across the x-axis twice, or to the number 2, and then up to the number 3. So 2, 3. Now, essentially, when it says x plus y equals 7, we need these 2 numbers to add up to give me an answer of 7. So which of these pairs of numbers, when added together, give a sum of 7? Well, it's going to be 3 and 4. So that's what we're looking for there, 3 and 4. ABCD is a parallelogram. Which side is parallel to AB? Circle your answer. So a parallelogram is a 4-sided shape, a quadrilateral that has got 2 pairs of parallel sides. So we're looking for AB. So that is this line here, AB. Okay. So which side is parallel? Well, parallel means they will never cross. Now you can see here that BC, that would cross with AB, and so would AD. So we're left with this one here. These two lines would never cross, they're parallel, like train tracks. Okay, so what did I say? CD? There we go, CD, 1 mark. So they are parallel lines. Draw a chord on the circle. So a chord is essentially a line that goes from one edge to the other, but without going through the center, essentially. So there's a nice example of a chord. You may have one that looks like this. You may even have one that looks like that. That is absolutely fine. So a chord is a line that goes through one side of the circle to the other. So there's 3 examples of what your chord may look like. Question 4C. Draw a trapezium on the grid. Now, there's kind of two types of trapezium. Now, a trapezium is a 4-sided shape and it's got 1 pair of parallel lines. Now, I'm going to try and draw this freehand, but hopefully you can see the red line on your screen. But yeah, here is one example of a parallelogram, of a trapezium, sorry. So the top and the bottom, those lines would never meet. So there's one type of trapezium. Let me draw another one just so you guys can see what another example may look like. Apologies for my terrible artistic skills. You can go across here like that, and then all the way across. So these are 2 types of trapezium. One with a right angle, which we've got here, and then one here where we've got 2 inverted sides. But yeah, the top and bottom never meet. So trapezium, something along those lines. Okay, now practice those, because you never know what could come up in an exam, so make sure you're aware of what a trapezium is, because that's a very nice 1 mark question if you know what trapezium is. Okay, write 4/10 as a decimal. Now, use a calculator for a question like this, because some of you may know instinctively what it is. That's fine. But what if you get a tricky decimal, a tricky fraction? You're not too sure how to immediately convert that. Well, a calculator is your next, your best friend in this sort of situation. So press the fraction button, which is, I don't know if you guys can see. Oh, no, bit of a blur. But a fraction button, you should be able to identify it. It looks like a fraction. Type in 4/10, press equals, and then press the SD button, and that will change it from a fraction to a decimal. Like I say, some of you may instinctively know that 4/10 is 0.4, but what if you had an example like this, like 3/8, and you're not too sure what that is straight away? Well, like I said, fraction button, 3/8, press equals, press the SD button, and we know within seconds, that gives me 0.375. So the examiner really there is just testing your ability to utilize the calculator in doing a conversion. But yeah, once again, 1 mark for 0.4, and then there's another example there, 3/8. Question 5B. Let's have a look. What number is the arrow pointing to? So we have numbers here between 0.2 and 0.3. Now, there are 10 lines that split those 2 values, 0.2 and 0.3. So each one of these represents a 10th. So this one is 0.21, 0.22, etc., etc. Okay. Now, if we continue that, 0.23, 0.24, 0.25, 0.26, this one is therefore 0.27, and that would be my answer. So identify your top and the bottom of your number line and how much it's split into. So if it's split into 4s, then it'll be quarters. But if it's 10, it'll be tenths. So the numbers will increase by a 10th each time. Okay. Now, sometimes it helps identifying the middle value. So you're like, oh, right, what's in between 0.2 and 0.3? Well, it'll be 0.25. And then as soon as you can sometimes see that, then you think, oh, that must be 0.26. And then that one must be 0.27. So yeah, either identify what they're going up in or try and find the middle value and utilize that to help you work out the number you're after. Question 6, 11/20ths of 660. Now, once again, there's 2 ways you can do this utilizing your calculator. I'll show you the first traditional way that we normally teach, and that is divide by the bottom and then times by the top. So we take the amount, 660, and we divide it by the bottom number, which is 20 in this example. So 660 divided by 20 is 33. And then once we have that value, we then multiply it by the top number. 33 times by 11, which is 363. Now, that would get you 2 marks. I'm happy with that. There is a shortcut though, and often a quicker way to do that. And that's by, once again, utilizing the fraction button. So type in the fraction that you want. So 11/20, move it across, and then times it by the amount that you're after. So the word of means times. Remember that, of means times. So on my calculator, this is what it looks like on the screen right now. So 1120 times by 660. And when I press the equals button, I get 363. You know what's good about having two methods for a question? You can check. So you could do it this way and then use this method to check, or you could do it the first way and then use the second way to check. So in an exam, you know, feel free to use both ways, because I can leave this exam right now knowing that I've secured 2 marks because I've done 2 effective methods that give me the same answer of 363. Okay, so always get into that briefly. No, we're still good. We're still connected to the internet. Excellent. Okay, so we're going to move on to question 7. Factorize fully 5xy plus 15x. Now, when it says factorize, that means brackets. So straight away, my answer line needs a pair of brackets in there like so. Okay, so remember factorize, and someone mentioned in my lesson the other day, think of bractorize. Don't know if that will help you or not, but there we go. Factorize, bractorize. Okay, I need to look at this. So let me just write this bigger so you guys can see it. 5xy plus 15x. Now on the outside of my bracket, I need number and terms and, you know, letters and all sorts that goes into both of these. Well, I can see that there's a 5 and a 15. And the biggest number that goes into both 5 and 15 is the number 5. So I'm putting 5 on the outside. I can also see, I'm going to highlight this here as well, just to make it clear, that there's an x on the left and on the right term. So there's an x on both sides. And if it's on both sides, it belongs on the outside of the brackets. So we've got 5x on the outside now. I can now focus my attention to what goes on the inside of the brackets. Okay, so how do I get from 5x to 5x? Why? Well, it's missing missing a y, isn't it? So I need to put a y there, because 5x times by y will give me 5xy. So that's that bit done. There's a plus symbol, so let's make our lives easy and put a plus symbol in the middle. And then we've got 5x, and I want to try and get 15x. Well, how do we get from 5 up to 15? I times it by 3. Now, the x that I'm after here is already on the outside, isn't it? So I don't actually have to put anything else on the inside. I am done. I have achieved those 2 marks, okay? So whenever you see the word factorize, think of brackets. And this is crucial here. You know, it says factorize fully. That's where it wants the biggest number on the outside. It wants the biggest values on the outside, rather than it being the smaller values, okay? Question number 8. Mo thinks that 5 times 3 squared equals 225. Explain why Mo is wrong. Now, I saw a lot of students do this in class last week. They got their calculators out, which is good. They did 5 times 3 squared equals 45, and they wrote that down. Now, unfortunately, I don't think that would get you the mark in an exam, because you're not actually explaining why. You're just doing the calculation. What did Mo do wrong? Well, 5 times 3 squared. What Mo has done is he's done 5 times 3 first. He's done 5 times 3 and then squared that answer. So 5 times 3 is 15. 15 squared is 225. So what has he done wrong? He's not followed the rules of bid maths. Bid maths, just as a quick reminder, means we have to do the brackets, the indices, division or multiplication, then addition or subtraction in that order, okay? Now, indices, these bad boys here, they come first. So what does he need to do first? 3 squared. So you could put Mo did not follow bid maths. He should have, run out of space here, have done 3 squared first. Something along those lines. Because the examiner then will be like, yeah, this student knows that bid maths is important, that Mo hasn't followed it, and that the 3 squared should have been done first, or the indices should have been done first. Well, worth 1 mark. But I know, guys, often when you have to explain someone is wrong, really try and look at what they've done and spot, right, imagine what, if they were sat next to me in a classroom, you'd point your finger at their work and say, you've done that bit wrong. You went to do the 3 squared first, Mo, not 5 times 3. Come on, that's what you'd say to him. Anyway, 8B. Insert brackets to make the calculation correct. Now, this is, I don't want to say it's like a trial and error sort of approach, because sometimes there is a bit of a knack to these, but in a worst case scenario, trial and error will work. So let's just have a look. So it's an insert bracket. So now I'm going to practice by just putting one set of brackets in across this calculation. So let's just write these down first and foremost. So 3 plus 6 times 9 minus 4. And I want an answer of 33. That's my goal every time. And I'm going to show you what I'm doing first and foremost, just so you know what my strategy is. I want to do these 3 times because at first, unless I need double brackets, but we'll cross that bridge if I'm not successful at this point. So let's have a look at the 3 potential places. Well, I could put it around the first pair of numbers, 3 and 6. I could put it in the middle, around 6 and 9, and then I could put it around the end. They're the 3 different places I could put the brackets. So what I'm going to do now is actually put that into my calculator. Like, I've got my little best friend here. Let's put it into calculator. So 3 plus 6, close the brackets, times 9 minus 4. That gives me 77. Definitely not there. Definitely not that. Let's try the middle one. 3 plus, open brackets, 6 times 9, close brackets, minus 4. That gives me 53. So it's not that one. Remember, I'm after 33. Remember, look up here. I'm after the answer of 33. Let's have a look at this one. 3 plus 6 times, open brackets, 9 minus 4, close brackets. Boom. That is what I need. There we go. There's the 33 that I'm after. So on my answer, or what I would do, is then put the brackets around the last 2 pairs of numbers, there and there, like so. And that'll get me 1 extra mark. Boom, boom, boom. Good stuff. Okay, so now I'm getting on to some of the juicy questions. We're kind of approaching we've done the first third of the paper almost. We're now going to get into the good stuff. Here is a straight line drawn on a pair of coordinate axes. Okay, we'll write down the equation of the line. Now let's just make this as simple as we can. This line here, okay, it crosses through the y-axis. So it's going to be y equals. What number does it pass through? It crosses through the number 3. Y equals 3. Done. It goes through the y-axis at the number 3. There's my answer now. Based off of that, I put in another line, just as a little extension now. That line there, just briefly, as I have a drink, what is the equation of that line? Have a little look at it. Get really close to the screen if you need to. Have a look. What do you reckon the equation of that line is? Okay. This line here, it crosses through the x-axis, doesn't it? It goes through the x, so it's going to be x equals, and it goes through minus 4, so it'll be x equals minus 4. Done. 1 mark, nice and easy. Now, these are the juicy questions. These are the questions that I think students often leave because they're not too sure about how to answer them. So if we have a strategy for a question like this, then we are giving ourselves that chance of being better than the average student, being better than the rest. So let's try and push for that. Here is a straight line drawn on a pair of coordinate axes. Yeah. Okay. On the grid, this is it. Question B now. We're moving on to B. On the grid, draw the graph y equals x. So what I'm going to what I'm going to draw is a little table of values here with my x value there and then my y value going to go underneath. And I'm going to split that up into a few just like so. Now, let's just choose some of the x values. So the x values here are across the middle here. And life's easier using positive numbers. That's what I truly believe. So I'm going to use the numbers 1, 2, 3, and 4. Okay? Because they are also on that grid, which is brilliant. Now it says here y equals x. And in other words, essentially, whatever x is, y is as well. So if x equals 1, y also equals 1 because they equal the same at y equals x. X equals 1, y equals 1. So if x is 2, y is 2. If x is 3, y is 3. And if x is 4, you've guessed it, y equals 4. Now, what do I do next? Well, I actually have to plot those points. So x is 1, y is 1. So across the x-axis 1, up 1 for y. There we go. Now, the next one is 2, 2. So across 2, up 2. And then 3, 3. And then hopefully you guys will see there's a bit of a pattern emerge. Now, you don't actually have to plot every single point. You can plot enough points to show where the straight line would be, and then you draw that straight line. Now, I'm going to probably embarrass myself here trying to draw a straight line, but what would you guys do in an exam? You'd use a ruler and you draw the line all the way through the points from the very top to the very bottom. Actually, I'm going to give myself a 9 out of 10 for that. Freehand. But yeah, you draw a straight diagonal line all the way through the points. And then you'd have a nice straight line and you'd have those marks. Happy days. Okay, so that's how your line should look. Okay. A pile of 500 sheets of paper is 5.3 centimeters high. 100 sheets of the paper are used. What are the height of the remaining pile of paper? Right, let's just write this down. So 500 sheets equal 5.3 centimeters. Now, I have a method, it's called the unitary method. And essentially what that means is going down to 1. Well, what would one sheet, what would that height be? Okay, so let's think about this. One sheet. This paper, remember, so it's quite thin. So we're going to go from 500 down to 1. How do I do that? I divide by itself. So any number divided by itself gets you 1. So 500 divided by 500 gives you 1. Okay. Let's think of another number. Let's go for 622. 622 divided by 622 gives you 1. So any number divided by itself gives 1. Now, whatever you do on one side, you have to do on the other side. Okay. Let me just fix up that that arrow for you there. So if we've divided by 500 on one side, we must do it over here as well. So we're going to do 5.3. I'm going to divide it by 500. That's going to give me an answer of, it's a decimal, and that's expected. It is a calculated paper, 0.0106. It's tiny, isn't it? But remember, have I got any paper with me? Paper is very, very thin, like almost naked to the, almost it's very, very thin. Let's put it that way. So we know one sheet is 0.0106 centimeters. Now, 100 sheets of paper are used. So what I'm going to do, I'm going to times this by 100. Because that'll tell me how much paper I need to remove from that pile. Okay, the height. So that'll give me 100 sheets. So we're going to do 0.0106 times by 100. And that tells me 100 sheets of paper is approximately 1.6 centimeters high. So in order to work out the remaining pile of paper, we need to take the original height and take away the sheets that have been lost or used. So we're going to do 5.3 centimeters, and we're going to subtract the 100 sheets height, which is 1.06 centimeters. 5.3 subtract 1.06 gives me 4.24 centimeters. And there we go. So it is a bit bizarre, but it's called the unitary method. Go down to what one is worth. When you know what one thing is worth, whether it be price, cost, height, whatever it may be, you can then scale it up to what you're after. And you'll see later on in the exam that I'll utilize this method maybe once or twice more. So it's a very good method to have in there. A map is drawn using the scale of 1 centimeter to 8 miles. The distance between two towns on this map is 7.5 centimeters. Work out the actual distance between the two towns. So what's important here is to write this down in a way that we understand quite simply. So 1 centimeter equals 8 miles on this map. Okay, now I want to know the distance between two towns, that is 7.5 centimeters. So let's put 7.5 centimeters on this side next to the centimeters. I want to know what it is in terms of distance, in actual distance in miles. So how do I get from 1 up to 7.5? I times it by 7.5. So whenever you know what the number 1 is, if you want to get it somewhere, you times it by where you want to go to. So if I wanted to know 10 centimeters, I do 1 times 10, for example. But in this question, it says 7.5. So I'm timesing, multiplying by 7.5. And whatever I do on one side, I do on the other side. So I'm going to do 8, and I'm going to times it by 7.5. That's going to give me 60 miles. So 7.5 centimeters on the map is equivalent to 60 miles in real life. And that is my answer, 60 miles. Okay. Question 12. I like these questions. I do like these questions. Like, an equilateral triangle has a base length of 3p minus 4 centimeters. Write expression for the perimeter of the triangle. Now, there's a few things we should pay attention to. That is the word equilateral, which means all sides are the same. Okay, it means this triangle, all the sides are the same. And these little symbols here also represent that. So two things that give you a clue that if the base is 3p minus 4, then this side as well is 3p minus 4, and then this side over here is also 3p minus 4 centimeters, okay? Now it says here, question A, write an expression for the perimeter of the triangle. Now an expression is algebraic, so we have to think in terms of algebra now. But what we've done already is we've highlighted the fact that all these symbols, or this base side is the same as the other two, okay? So essentially what I've just highlighted there are all the p's. How many p's do I have? Well, I've got 3 lots of 3p, so that's going to give me 9p, okay? So that's that bit done. I've got 9 p's so far. Now let's just focus then on the minus 4s. So let's just circle or highlight the minus 4s. I've got a minus 4 there, I've got a minus 4 there, and I've got a minus 4 here. Altogether, how many minus 4s do I have? Well, I've got 3 lots of minus 4, which would give me minus 12 centimeters. So 9p minus 12, 9p minus 12 centimeters. I'm sure you'll get the mark for both of those. Okay, so that is taking what we know and utilizing to create an expression to represent the perimeter. Okay, now that leads very nicely onto this next question for 12b. So it says here that the perimeter of the triangle is actually 141 centimeters. So do you know how briefly we mentioned there it was 9p minus 12 is the expression for the perimeter? We now know that the perimeter has an actual value. So what I'm going to do, I'm going to write that down. So 9p minus 12, that is the perimeter. And it actually equals something now. We've been told it equals 141. We're going to turn that expression into an equation by putting this equals symbol in. Now, the fun bit about this is now we have an equation, we can solve it. Now, you might be thinking, Sam, that's a weird idea of fun, but hey, it is what it is. Now, when you solve an equation, think of these 3 words. Do the opposite. So if you can see here, minus 12, we have to do the opposite of that and plus 12, okay? Now, I always get rid of this little dangly bit. The 9p is pretty tight, but the minus 12 is just chilling there. Let's get rid of that first. So we get rid of a minus 12 by adding 12. And whatever you do to whatever you do to one side, you do to the other side. Okay, so on this side now, I'm left with 9p. And on this side, I've got to do 141 add 12. Now, call me lazy, say what you want. I'm using a calculator to do this. I'm making sure I'm not making any silly little mistakes. So 141 add 12 is 153. Now, the last thing I need to do is the opposite. Now, it says here 9p. That means 9 multiplied by p, or p multiplied by 9. What's the opposite of timesing by 9? Dividing by 9. And whatever you do to one side, you do to the other. So I'm going to finish up one step away now. P equals 153 divided by 9. And that's going to give me 17 centimeters. Just to be nice. Yeah. So there we go. We formed an expression. We turned it into an equation, and then we solved that equation. So there's a few ways you can do that, but if you get 17 as your final answer, hats off to you. Well done. Question 13. Now, this is purely your ability to utilize a calculator. Okay, so it says here, work out square root 2.786 divided by 0.65 minus 0.228. Now, there's 2 ways. When I've seen this in the classroom, I've seen 2 different answers. Now, the best way to do it, if you can see you've got there a fraction, press the fraction button first and foremost, and then do the top line, move it down, do the bottom line. Some students that I've seen, they press the square root button first, which I understand because that's kind of what your eye leads you to. However, when you press the square root button, type it in, and then the fraction button, you end up square rooting the entire equation. You end up square rooting all of it, which would give us the wrong answer. So press the fraction button first. If you ever get given a fraction like that, press the fraction button first. It'll help you arrive at the right answer. So fraction button, square root button, 2.786. Drop it down. 0.965 subtract 0.28 equals. Write down all the figures. Are you ready? It's going to be fun. 2.4366 8833 88337. There we go. Quite long. Just make sure. I'm going to check. 2.4366 883337. Good. Just do a check. Don't rush it. Don't just be like, yeah, that looks good. Because if you make one small mistake there, that could lose your mark. And how frustrating that'd be to lose a mark when you've got the answer literally in front of you. Now it says here, write your answer to part A correct to 2 decimal places. So let me just copy that number down again, because I want to make it nice and clear for you all at home. 2.4366888337. Now it says 2 decimal places. So I need to identify the second number after the decimal point. So there's the first number, there's the second one. Now I'm going to draw a line between the second decimal place and the third. Because the third decimal place, this number here, the number 6, that's going to tell me what's going to happen to the 3. If it's 5 or more, this 3 will be rounded up. If it's 4 or less, that 3 stays the same. But as you can see, it's a 6. So that's going to round up the 3 to a 4. And then that's going to become a 4 as well, 2.44. There's my final answer. Okay, and then I've squeezed in at the bottom here, question C. Evaluate -4 cubed. Now, evaluate, don't worry necessarily about that. Just basically give the answer to -4 cubed. So -4, press the cube button, -64, done. Now, some of you may know that when you cube a number, you're timesing it by itself 3 times. So you're doing -4 times by -4 times by -4. So if you want to use that as a check, if you type in your calculator -4 times by -4 times by -4, and you press equals, you'll get the same answer. So once again, if you know there's 2 different ways to get to an answer, do them both, use a calculator and check. Well, that gets you 2 marks for this, 1 mark for that, 1 mark for that. 4 marks for being pretty nifty with a calculator and being able to round to a decimal place. So not bad, not bad. There are nice marks on an exam paper by using a calculator quite comfortably. Okay, question 14, here we go, coordinates. Write down the coordinates of point A. So remember earlier, I mentioned this, you go X and then Y. So you go along the corridor, up and down the stairs. So along the corridor to 3, up to 2. So in brackets, 3, 2. Now always remember your brackets. It's a set of coordinates, always brackets. Now you'll see on this next bit of information here, you'll see it says here -1, -2. That's a good reminder. It tells you literally on the next question, coordinates should belong in brackets. Okay, so for point A, 3, and then 2. Okay, let me just clear my answer from A now. There we go. Now let's look at point B. Point B has coordinates -1, 2, plot it. So -1 up to 2. There is B. I've gone -1 across, 2 up, -1, 2. Happy days. That's B done. Now C is one of the most interesting questions with regards to midpoints that I've seen. Quite good. It gives you the midpoint. The midpoint of line segment AC. So there's a line here, AC. There's no C on here. We're going to have to give the coordinates to C in a minute. It says here, the midpoint of line segment AC is 1, 0. So across 1, up and down 0. There is the midpoint. So MP for midpoint. Work out the coordinates of C. So I know A is over here, the midpoint of AC. So C is going to be over here somewhere. Now, my best advice is to work out how you get from A to the midpoint. So you go down 2 and then across 2. Okay, so down 2, across 2. And then you do the exact same from the midpoint. Go down 2 and then across 2. And then that will take you to where C is. Work out the coordinates to C. Well, it's going to be -1, -2. Now I've realised it might be because I'm left-handed here, but those down, these ones here, are not the cleanest. So let's do it again, and we'll reinforce the fact C is where I've said. So we're going to go down 2, like so, and then across 2. Yeah, much better lines there. So down 2, across 2, down 2, across 2. There is C, -1, -2. Brilliant. So use the midpoint. Work out how you get from one coordinate to the midpoint, and then do the exact same. Continue that, okay? A straight line has an equation, y equals 4x plus 15. Write down the gradient. Now the gradient, let's not overcomplicate this. The gradient is the number before the x. So it's 4. Done. Let's not overcomplicate something that doesn't need to be overcomplicated. A straight line equation, so it would be y equals something x plus or minus another number. The gradient is the number before the x. Okay, let's just do another example up here. Y equals 3x minus 2. The gradient is 3 because it's the number before the x. Okay, so really important that we remember that gradient is the number before the x. Okay. Now this is the trickier question because it has caught some emotions. Write down the coordinates of the y-intercept of the line. So remember earlier I said every coordinate has an x and a y. I've said it a few times actually, I think. The y-intercept, well, that's where the line would cross the y-axis, okay? So the y number is 50. Now, let me just highlight this. The x, the number before the x is the gradient. The other value is the y-intercept. So in this case, it's 15. Plus 15 is going to be 15. Okay, now the x value is always 0. The x value is always 0. So no matter what, if you need to give coordinates for a y-intercept, always put 0 and then the other number. 0, 15. Done. Okay, always put 0 and then the other value. That's in the equation. Okay, rice is sold in 2 sizes of bag. Which bag is better value for money? You must show you're working. Now, there's a lot going on with this question, and it's quite interesting really, because what they've done, they've tried to catch you out twice over, because they've given the rice in different units. One's in grams, one's in kilograms, and then they're giving the money in different units. One's in pennies, one's in pounds. So really, to make our lives easier, we need to convert them both into the same. So when we make our conversions and our comparisons, we're comparing the same thing. It's a bit like comparing Roger Federer to Tiger Woods. They're 2 different sports. So it's very hard to make those fair comparisons. But if you make them the same, they compete in the same sport, you can at least give that, make that calculation. So what we're going to do, we're going to convert this bag here, 1.6 kilograms, into grams. Now, there's 1,000 grams in 1 kilogram. The clue for me to remember that is a K is 1,000. So if I see a K, I think 1,000. So this one here is 1,600 grams. 1,600 grams. Now, that's good. I can forget about the 1.6. Let's get rid of the decimal. Okay. Now, the question is now, would you rather work in pennies or pounds? Pennies or pounds. Now, it doesn't necessarily matter which one you opt for, as long as you convert correctly. Now, I prefer working in pounds. Most things in life you end up paying in pounds. So I'm going to convert 79p into pounds, which would be 0.79. Okay. So let's get rid of that 79p. So 300 grams is 0.79 pound. 1,600 grams is £3.99. Now, this is the next bit. This is where we're going to earn our money here and get our marks. So 300 grams equals 0.79. I'm going to write that down here. And then over here, I'm going to put 1,600 grams equals £3.99. Now, we can't really compare them at the moment because they're different weights. So what we're going to do, we're going to scale it down so they're the same weight. Okay. And the number that I've got in my head is 100 grams. Because 300 goes, well, 100 goes into 300. But also 100 goes quite nicely into 1,600, okay? So the only question I have to ask myself now is, well, how do I get from 300 down to 100? Well, I divide it by 3, okay? And whatever I do on one side, I'm going to do to the other. So I'm going to take my calculator now, I'm going to do 0.79. I'm going to divide it by 3, which gives me 0.263 recurring. 0.263 recurring decimal. So that's approximately about 26 and a bit p. Now, let's look at the next one. 1,600 grams. Well, how do I get from how many hundreds go into 1,600? Or how do I get from 1,600 down to 100? I divide by 16. I essentially divide by the number in front of the zeros, okay? And whatever I do on one side, I do to the other. So now I'm going to do 3.99 divided by 16. I'm going to get 0.24, right, it's a bit of a long one, this one, but it's okay, you'll see why. 0.249375, 249,375. Now, a bit long, but hopefully you guys can see one of them is cheaper than the other. The smaller the number, the cheaper it is, okay? Now, 0.249375 is about a penny and a bit cheaper than the other. So this is our best value. Where would you get your marks then? Well, the examiner is going to be looking for a comparison to be made with these numbers, and it'll be looking for you to make that final decision, saying, 1.6 kilogram bag, something like that, is better value. Okay, so yeah, you must show your work in, but you must also give a definitive answer. In a park, the ratio of boys to girls is 2 to 3. What percentage of the children are boys? So let's just quickly write this out. I'm going to change my color to red. There we go. So 2 to 3. So this is a ratio. And I always like to label my ratio so I know what I'm dealing with. So it says boys to girls. So it's going to be B and then G. Okay. Now, what percentage of the children are boys? Now, I think personally for me, it's a lot easier to turn it into a fraction. And then that fraction you can then convert into that percentage that we're after. So 2 to 3. Well, how many parts are there in total? Well, 2 add 3 is 5. So my fraction is going to be out of 5. And then we only care about the boys, which represents 2 of the ratio. So it's going to be 2/5. Now, remember earlier I said turn a fraction into a decimal is quite nice, because you press the fraction button, press equals. Yes, D is 0.4. So give us a decimal. And then how do we convert a decimal into a percentage? We times it by 100. So 0.4 times by 100 will give me 40%. There we go. So turn it into a fraction, make some conversions, and then times it into a percentage by timesing it by 100. But there we go. Write the ratio. So this is for 17B now. Write the ratio of girls to boys in the form 1 to n. Okay, so 1 to n. But girls, cheeky this, they've gone, so instead of it being boys to girls, it is now girls to boys. So it's going to be 3 to 2, not 2 to 3 like it was. So make sure you read the question carefully. Now we want it in the form 1 to n. So directly underneath that ratio and put in 1 to n. Now I have to use the side with the 1 on it. That's what I tell myself. I always use the side with the 1. Okay, so that's the left-hand side. And I ask, how do I get from 3 down to 1? Well, I divide it by itself. So I divide by 3. Now, whatever I do on one side, I do to the other side. So I'm going to be doing 2 divided by 3. Now, there's 2 ways you can give your answer here. I'm happy with either, and so would the examiners. You can either give it as 0.6 recurring, which is what it pops up on a calculator, or you can leave your answer as a fraction. You could do 2 over 3. Either of those, absolutely fine, because the examiner is going to be looking, because they're equivalent. 0.6 recurring is exactly the same as 2/3, but one is written as a fraction and the other is as a decimal. So either of those is absolutely fine. But yeah, identify the ratio. Underneath it, put 1 to n or n to 1, whichever the question specifies. Use the side with the 1 on it. Okay, so in this case, it was the left-hand side, and then divide by that top number. And then what we do on one side, do to the other side. Okay. Okay. In October, Whitney scored 32 marks in a test. In January, Whitney scored 12.5% fewer marks than she did in October. How many marks did Whitney score in January? So 12.5% fewer marks than she did in October. So essentially what I need to do is work out 12.5% of the October score, which is 32, and then subtract it, take it away because it's fewer, and that'll give me her January score. Now, we're using a calculator on these papers, so let's make our lives nice and easy. This is what we're going to be typing into our calculator today, or for this question. Type in the percentage that you want. So I want 12.5%. So type 12.5. Press the shift button and then the percentage button. Now this may vary on calculators, but look for the shift button and then the symbol with the percentage. It'll pop up exactly like that, 12.5%. Remember, times by the amount that you're after, which in this case is 32. And that's going to tell me 4 marks. That's my answer, 4 marks. So she drops 4 marks. So what do we need to do? We need to take 32 and subtract the 4, which will give me 28. So unfortunately for Whitney, she dropped 4 marks, which means her final score in January was 28 marks. But yeah, use a calculator, guys. Don't worry about finding your 10% and your 1%. If you have a beautiful, calculator device in your hand, use it. Make your life easier. Okay. Now this question here, I've tried to, get it all on screen. So I apologize if it's slightly small, but I thought this was the best way to display it. So it says here, 2 boxes each contain some counters. 3 out of the 10 counters in box A are red, the rest are blue. 4 out of the 7 counters in box B are green, the rest are yellow. It says here, complete the probability tree diagram. Well, let's focus on box A first. So you've got 3 out of 10 chance of getting red. Well, on the flip side of that, if 3 of the counters, or 3 out of the 10 counters are red, then let's say there's going to be 7 tenths blue, because those two together will give me 1, which is what we're after. So 3 tenths, 7 tenths. That's definitely a mark. Now, the same for box B. If there's 4 sevenths green, then there must be 3 sevenths yellow, because 4 and the 3 together will give me the total of 1. Now, green and yellow is repeated, green and yellow. So what we need to do is bring that down here as well. So 4 sevenths and then 3 sevenths. Done. That's it. Okay. So then, Sam chooses 1 counter from each box at random. Find the probability that she chooses a blue and a yellow counter. So blue here and yellow here. So once we've identified that, we then look at the fractions involved. So we've got blue 7 tenths and then yellow 3 sevenths. I'm just colouring it in, make it stand out. So it's exactly what I would do in an exam. I'd circle the fractions that I needed. Now, to work out the fraction, the probability of them both happening, we times them together. 7 tenths times by 3 sevenths. Now, some of my students last week, they use the heads, which is fine. But once again, if you've got a calculator, use a calculator, or at least do it in your head and then check with the calculator, because the calculator, unless you type it in terribly, will give you the right answer every time. So 7 tenths times by 3 sevenths will give me an answer of 3 tenths. Done. That is a probability of it both happening. So yeah, identify the two and then times them together. So you, to find out the probability of one happening and then the other, you times across. Okay? A quick drink. Okay, convert 216 minutes into hours and minutes. Now, I don't think we should try and overcomplicate this with using a calculator or anything like that. We know that there's 60 minutes in an hour, okay? That has never changed. So let's just tot up 60 minutes. 60 minutes for 1 hour. 2 hours would be 120 minutes. 3 hours would be 180 minutes, you know, as I'm adding 60 each time. Now, if I add an extra 60, that takes me up to 240, which is too many minutes. So it's definitely not 4 hours. So straight away, I know there's 3 hours. Now, what I've got, though, is a gap between 180 and 216 minutes, because that's in minutes. That's in minutes. So to work out the minutes left over, I can just simply take away 180 from 216. So 216 subtract 180 will tell me that there's 36 minutes gap between those two values. So I've got 3 hours and 36 minutes. Like I said, I'm not trying to overcomplicate that using the calculator or anything like that. I'm just using my time, totting it up, and then working out the gap as my remaining minutes. Okay? I like this question. I do like this question. When is it 6 a.m.? Let me start again. When it is 6 a.m. on Wednesday in London, it is 10 p.m. on Tuesday in Vancouver. Work out the time in London when it is 7 a.m. Wednesday in Vancouver. Now, with this question, I'm going to start on Tuesday, because in terms of days of the week, Tuesday comes first. So I'm actually going to start with Tuesday in Vancouver. So let me put Tuesday, 10 p.m. Vancouver. I've spelled that right. Yeah, brilliant. Okay, I'm not embarrassed myself. Now, when it's Tuesday, 10 p.m. Vancouver, it is 6 a.m. on Wednesday in London. So Wednesday, 6 a.m. London. So I need to get from here to here. I need to know what that time difference is. Well, from 10 o'clock to midnight is 2 hours. And then from midnight to 6 o'clock, it's 6 hours. So altogether, that's 8 hours. So London is 8 hours ahead. So now I know that, I can actually look at the next bit here. So it's 7 a.m. Wednesday in Vancouver. So let's keep Vancouver there. Let's put Wednesday now. And then it's 7 a.m. And I know to get to my London time, which is where we're going to, London. Yeah, work out the time in London, brilliant. I need to add 8 hours. So to get from 7 a.m. to 12 midday, it would be 5 hours. And that leaves me with 3 hours left over. So it would take me to 3 p.m. in the afternoon in London. Wednesday, the same day. Now, in the exam, I put the day and the time just to really reinforce to the examiner you know exactly what you're doing, okay? So Wednesday, 3 p.m. Don't leave it to chance. Don't let the examiner think, what day did they mean? Just put in there, Wednesday, 3 o'clock, okay? So yeah, what did I do? I worked out the time difference and then applied that time difference to the next set of dates and times that I was given. Okay, Wednesday, 3 o'clock. Circle the prime number. Now, a prime number can only be divided by itself and the number 1. So if I can think of any numbers that times together to give these, then I know it isn't prime. Yeah, so there's only one even prime number, and that is the number 2. 2 is the only even prime. So knowing that, 22 can go and 24 can go. Why? Well, 2 times 11 gives me 22, and 2 times 12 give me 24. So straight away, not prime. So then that makes my life a lot easier because I'm left with 2 numbers now, 21 and 23. Well, 2 doesn't go into 21, but I know that 3 does, because remember, 3 times 7 gives 21. So 21 can't be prime. By simply process of elimination, I've identified 23 as my prime number. Now, I'm going to show you or talk. I don't know if hopefully this helps, but there's a little button on a calculator that helps you identify prime numbers as well. So let me just talk you through this. So let's type in on a calculator, type in the number 23, press equals. Now, on your calculator, if you can see it, there's a word that says fact. Fact, okay? Now, press the shift button and then press fact. If the number stays the same, it's prime. Okay, so 23 stayed the same then. Let's think of another number. Let's go for 180. Now, I know this isn't prime. I know it isn't. So if I type in 180, press equals, and then press shift fact, it changes it to its products of its prime factors. So 2 squared times 3 squared times 5. That essentially means that 2, 3, and 5 all go into 180, so it's not prime. Let's do one more. Let's do 191 equals shift fact. 191 stays the same. So just by quickly doing that, I know 191, it's a prime number. So shift fact. There we go, shift fact. I know sometimes I don't pronounce words very well, so I'm trying my best to make that easier for you guys. Okay, calculate the area of the shape. Straight up, no jargon, just work out the area of the shape. Now, there isn't really a magic formula for this sort of shape. So what we're going to do, we're going to make our lives easier, because let's try and make stuff easy if we can. Let's split the shape up into two rectangles. Now, I'm going to go for a cross here. So if you split it up in a different way, that's fine, because you should arrive at the same answer. I'm going to label that A and this shape down here B. Now, to work out the area of A, I need to do the base times by the height. Now, you'll notice that I've not actually got a value for here. So I need to use my brain and the information given to me to work out what that missing value is for the base. Well, if the whole thing across is 10, and then to this point here it is 6, then that must be 4 centimeters. So I'm going to be doing 4, and I'm going to times it by the height. Now you'll notice it's this height. It's not 9, because 9 goes all the way to the bottom, but this shape here stops at this point. So if it's all the way from 9 to the bottom, and this bit's 2, then this bit has to be 7 centimeters. So I'm going to be doing 4 times 7, which gives me 28 centimeters squared. And then the B, well, we've got the height as 2. Oh, we've been given the base. This is a nice one. It's going to be 2 times 10, which gives me 28 centimeters squared. Now, how do I work out the overall area? Whoa, wait a second, Sam. I got autopilot. How do we work out the overall area? We add them together. So let me just fix that, put 20. There we go. So 2 times 10 is 20. We're going to add them together. So we're going to do 28. We're going to add 20. And then that's going to give me 48 centimeters squared. Don't forget the units. Just show to the examiner area, centimeters squared, meters squared, whatever it may be. Okay? That's how I would do it in an exam. Split the shape up, make my life easier. Job's a good one. Now, I like this question. It's not something we've really covered in class this year. So if it did take you by surprise and confuse you, That's understandable. But let's look through it first. And then what I'm going to do, actually, I'm going to write it out bigger, just so it's clearer on screen for you all to see. 2x plus ay, and then identity, which is what that symbol is there. That's an identity, that is. So it means identical, essentially, either side. 20y plus bx. Now, whenever you see brackets with a little number on the outside, expand them. Expand the brackets, get rid of the brackets. Okay, and we do that by multiplying. So 5 times 2x is 10x. 5 times ay is 5ay, because we've got 5 lots of ay. And then identity symbol, 20y plus bx. Now it says here, work out the values of a and b. Okay, so what we're going to do, down at the bottom, we'll put a equals, and then I'll put b equals. That's what we're working towards. Now, an identity, this symbol here, this symbol means whatever's on one side is identical to what's on the other side. Identity, there we go. So it means identical. So if there's 10x here, and this is bx, we know the numbers are the same. So if that's 10, b also has to be 10. Has to be 10, okay? No ifs, no buts. It has to be. And let me just put this down there. There we go. So b is also 10. Because if that's 10x, then that has to be 10x as well. Now, what we're left with are the y's. So you've got 5ay is identical to 20y. So essentially, the question I have to ask myself is, well, how do I get from 5 up to 20? And that must be what a is, because we can times them together. Well, 5 times by 4 gives me 20. So a must be 4. No ifs, no buts. That's what it has to be. Happy days. That's known as an identity, okay? Okay, here's a list of numbers. 11, 7, 15, 3, and 5. A sixth number is added to the list. When the sixth number is added, the range increases by 2. Write down the 2 possible values for this sixth number. You must show all your working. So straight away, this is the important bit, the range, and it is increased by 2. So that's important. So what I would do first and foremost, show the examiner I know what the range is. I know what it means by calculate the range. The range is the biggest value take away the smallest value. Now the biggest value here is 15 and the smallest is 3. So I'm going to do 15 take away 3, which gives me 12. So the range right now is 12. But then going back to this sentence, it increases by 2. So if I do 12 add 2, I know that the new range for these values has to be 14. So whatever numbers I show, the 2 possible values, the range has to be 14. Now, there's 2 ways I can do this. I can either make the biggest number 2 bigger, or I can make the smallest number 2 smaller. Because that way, that will create that difference of 2, which is what I'm after. So remember, the biggest number we established was 15. So if I do 15 add 2, I get 17. So let's see if 17 could be a possible number. So if I do 17, the smallest number would stay at 3, wouldn't it? So 17 take away 3, yeah, is 14. So 17 is one of the numbers. So making the biggest number 2 bigger gives me that difference. Now, if we take the smallest number, which is 3, and make that 2 smaller, okay, so 3 minus 2 is 1, okay? If that could be the new value, let's check. So 15 would stay the biggest, and if we do 15, take away the 1 that we're suggesting, it does give me a range of 14. So there we go, 1. 17 and 1. Now, that's worth 3 marks. I'm not 100% sure where you get the marks. I want to think you get a mark for just understanding range and knowing that 12 and 14 are 2 crucial parts of that puzzle. And then you'd get an extra mark for 17 and then another mark for 1. So 12 and 14, you pick up a mark for one of those, and then 17 and 1 to get your 3 finale marks, okay? These are problem-solving questions. Really try and take your time with them, understand what the question wants. And if you're really unsure, just apply whatever maths you can to that question. If you're there like, I'm not too sure about that, Sam, if you just worked out the range and you knew the range got bigger by 2, you could pick up a mark for having that number 14 scribbled down onto your working out. Okay, pie chart. A group of people were asked their favourite sport. The results are shown in the pie chart. 48 people said that hockey is their favourite sport. How many people asked in total? Now, this is my, do you know the unitary method where I want to know what one thing is worth? This is where that comes in handy here, okay? So it says there, 48 people said that hockey is their favourite sport. Well, here's hockey, and that's 80 degrees. So let's put a number 48 there. So I know that 80 degrees of this pie chart is worth 48 people, okay? So let me write that down. 80 degrees equals 48 peep, okay? Now, if I know what 1 degree is worth in terms of people, I can then scale it up to work out all the degrees. So I'm going to go down to 1 degree. So 80, how do we get from 80 down to 1? We divide by 80. Remember, we divide by the number itself. 80 divided by 80 is 1. Yep, just checking. 48 divided by 80 tells me that 1 degree is worth 0.6 people, or 0.6 of a person, which is fine. Don't worry. Don't let that panic you. Now, my next question is, how many degrees are in a pie chart? Well, it's a circle, which means there's 360 degrees. What do I need to do? I times by 360. To get from 1 up to 360, I times by 360. Whatever I do on one side, I do to the other. So I'm going to do 0.6 times it by 360. Tells me there's 216 people. Now, that's a lot nicer, isn't it? There's no decimals. There's no awkward people left out. And it makes sense. You can't have half a person or a third of a person for everyone involved. So 216 people is my final answer, and that would pick me or give me the marks. Okay, question 26, expand and simplify. So thinking back a few questions ago, when I said expand, when you have to multiply the brackets out. So let's just do this nice, big and clear. Let's not leave anything, small and messy. And then plus. And I've changed the colour of my pen to make it hopefully stand out a little bit better. So let's have a look here. We've got first set of brackets, 3 times by 2p. So 3 times by 2p is going to give me 6p. 3 times by minus 5 is minus 15. 3 lots of minus 5 is minus 15. Plus, that's handy. 2 times p is 2p. And then 2 times 3 is 6. Now what I'm going to do, I've expanded, that's definitely worth a mark. Boom. Now what I need to do is group them. So I'm going to put all my p's together and then my numbers together after that. So I've got 6p. Let me highlight that, 6p. And then I've got plus 2p. Notice I'm including the symbol to the left because that's sort of my instruction. It tells me what the numbers are that I'm dealing with. 6p add 2p is 8p. Okay. Now I'm left with the other values. Let's highlight these in blue. I've got minus 15. Minus 15 plus 6. Minus 15 add 6. Now, on a non-calculator paper, I said, oh, might be worth drawing a number line. However, on a calculator paper, minus 15 add 6 gives me minus 9. Done. So on a calculator paper, don't make your life hard. Use your calculator, make it your best friend, have it in your hand. Job's a good one. So yeah, what I've done is I've just grouped the p's together, grouped the numbers together, done and dusted. Okay. Okay. Teddy buys a painting for £235. He sells the painting for £500. Calculate the percentage profit that Teddy makes. Now, this question involves a particular formula. You need to remember this because it won't be coming up on the exam. It won't be on the formula sheet. It is the difference in prices divided by the original and then times by 100. So you work out the difference between the two values or the two prices in this case. You divide it by the original cost or the original price, and then you times it by 100. So step 1, let's change the colour to red. Let's work out the difference between 500 and £235. So 500 take away 235 is £265. So the difference, let me write that up here, 265. The difference between the two prices, £265. We're going to divide that by the original cost. Well, how much did the painting cost originally? There we go, £235. And then I'm going to get my answer and times it by 100. So fraction button, 265 over 235, times it by 100. I get 112 points. Let me write this down. 112 points long. I'm just going to do a few of the decimal places. 76595 ... Now this bit's crucial. I'm going to highlight it so we're under no illusion that we've not missed it. Give your answer to the nearest 1%. So essentially what that's saying is we don't want any decimals. We want it to the nearest one value, the nearest unit. So the 7, the 7 will round the 2 up to a 3. So become 113%. That'll get you an extra mark because it's important, that bit. It's important. So difference, divide it by the original value and then times it by 100. Okay, that's known as percentage change. So if you're not too sure on that, let us know and we can give you some percentage change questions or send some videos your way and help you practice. Okay. Ooh, inequalities on a number line. My favorite. Right, write down the inequality shown on the number line. So basically what this diagram shows me is that a number can either be between this value and that value. So let's say we don't know what this number is. So whenever we don't know what a number is in maths, we typically put the number X, or we put the letter X, sorry. Now, when a line is filled in, a dot is filled in, it means it's greater than it or equal to it. Now, how do I remember that? So inequalities, there's different symbols, right? Like that. When it's coloured in, this is how I think of it anyway. There's more ink, isn't there? In that dot, there's more ink. And this, to draw that, you need more ink. You need an extra line, which involves more ink. So these two are paired together. Now this is just like that. So that's just what's the word I'm thinking for? That's a non-coloured in dot. That's just an open circle. So I know that this symbol represents that, and I know that this then represents that. So they're the symbols that I need. Now I just need to put the numbers in. So this one is -1, and this one is 4. Now these are known as inequalities on a number line. Now these are something that we don't typically stumble across in our lessons. So if you're struggling and unsure about these, please revise them. And if you want me to, contact me. I'll send you some work your way on these. I'll set you essential assignments and all sorts, okay? Inequalities on a number line. It's about turning the things that we're not too sure about into things that we are sure about. And that's what can get us these extra marks in an exam, okay? Question 29. Let's just check something here. There we go. I changed it. That's how your question does look, but for the purpose of the PowerPoint, I've moved it across to give you some working out space. So you will be given the formula for Pythagoras' theorem. Now, why do I know Pythagoras' theorem is needed? Well, I've got a right angled triangle, as you can see, and I'm missing a side. Okay, and I've got the two other sides. So I know Pythagoras is needed. Now, a squared plus b squared equals c squared. Okay, that's the formula you will be given. Now what you need to do is label the sides. Now c is always the longest side opposite the right angle. Okay, now a and b doesn't necessarily matter, but I always leave a as the blank and then I would label b as the other one. So a as the blank there. So what we're going to do now is actually substitute in numbers for the letters. So a will stay as a because we don't know what it is, but b can actually now be 12 squared, and then c can be 18 squared. Now, once we have that, we can actually start playing around with the numbers. So a squared, we can't square that. We still don't know what a is, but 12 squared, we can do. So I'm going to calculate 12 squared, 144. And then 18 squared. It's going to give me 324. Brilliant. Now, this bit's important. We've got a squared plus 144. Now, I want to get a by itself. That's my goal. I need to get rid of the plus 144, so I need to take it away. I need to do the opposite. So I'm subtracting it from both sides. So what's that going to leave me with? Well, on the left-hand side, it will leave me with a squared. And on the right-hand side, well, 324, take away 144, is 180. Okay? The final thing I need to do, notice here, a is being squared. So I need to do the opposite of squaring, which is a square root. And I do the same on both sides. So what does that leave on the left? Well, A is now by itself, which is what we want. And then 180 square rooted, drum roll, is 13.41640786. Now I'm writing it all down because I have just noticed that it says here, give your answer to 3 significant figures. So what I'm going to do, keep the examiner happy, is do that. So I need to identify the 3 significant figures. Well, the first significant figure is the 1, then the 3, that's the second significant figure, and then the 4 is the third significant figure. So significant figures, essentially numbers in their order. So 13.4, done. Now, I would round it, but because it's the 1, it keeps it the same. So my answer stays as 13.4, okay? 13.4 centimeters. Now, what I like doing in an exam is checking this. So if I put 13.4, does that look right? It does, doesn't it? We know it's not the longest side. We know it's not going to be longer than 18. 13.4 is smaller. So yeah, happy days. I'm happy with that. Okay, mean from a table, question 30. Now, this is interesting because like we're coming on to stuff that we've not really had a chance to cover in class this year. So this is where your revision could potentially be focused because we're doing things that we've not looked at yet. Or you may want to focus your revision on things that we've done, you know, in the early weeks and months of our academic year. But if you've got enough time, go ahead and look at all of it. It says here, the table shows the mass of 10 boxes. Work out the estimate or an estimate for the mean mass of the boxes. Now you'll notice here that the masses have been grouped together. So instead of us giving a list of 10 boxes with the exact masses, it said, look, one of them is between 0 and 2 kilograms, whatever it may be. 2 of them are between 2 and 4. 4 of them are between 4 and 6, etc., etc. Okay. Now, because they're not giving us the exact amount, we have to make a rough guess as to what their weight is. So what we're going to do is extend this across. Now, forgive me for my straight lines. We're going to extend this across, and we're going to do the midpoints. Now, this may sound familiar for some of you. We're going to do the midpoints. So the midpoint is the middle of these values here. So what is in between 0 and 2? 1. We'll put MP for midpoint, okay? What's in between 2 and 4? 3. 4 and 6? 5. 6 and 7? 8. 8 and 10? 9. So I'm making an assumption that they're all roughly about 1 kilogram, 3 kilograms, 5, 7, 9, etc. Now, what do we do next? Well, we're going to do the midpoint, and we're going to times it by the frequency. So that's going to say that one box was roughly about 1 kilograms, okay? So 1 times 1 is 1. So we're going to times them together. Two boxes are about 3 kilograms. So altogether, that's 6 kilograms in terms of their weight. 4 times 5 is 20. 1 times 7 is 7. 2 times 9 is 18. So that's roughly how much they weigh. Now, what we do when we find the mean is we add up the total and then divide it by how many there are. So I'm going to add up the total now to see how much all of these boxes weigh. So 1, add 6, add 20, add 7, add 18. That gives me 52. So that's the total weight. The last thing I need to do is divide by how many boxes there are. So I need to do 52. I need to divide it by how many boxes. Now, lots of people go 1, 2, 3, 4, 5. They divide it by 5. Not correct, because this is the groupings of them. This isn't the actual number of boxes. It says here, for starters, there's 10 boxes. So we should divide by 10. But if it doesn't say that, if it just says boxes, how would we know how many there are? We'd add up the frequency. We'd do 1, add 2, add 4, add 1, add 2. And let's just prove a point. 1, add 2, add 4, add 1, add 2. It does give me 10. So your frequency is how many boxes there are, how many items there are, which is 10. 52 divided by 10 is 5.2. So on average, an estimate for the mean is that if you were to pick one box at random, we'll take the average, it'll be about 5.2 kilograms or something along those lines. Okay. So it's a lot going on there. If I walked into a room now and I saw that on the board, I'd be like, blimey, there's a lot going on there. So if you need to, go back a minute or so, watch it again, draw your own table, do your own, see how you get on. Again, if you want, means from a table, this is what this is, give me a shout, I can send you a document, okay? Means from a table. Now, we don't know for definite what's coming up, but we've seen this on 1 or 2 predicted papers, so it could be mean from a table. And it's not a terribly hard skill, you just need to remember the process that is involved. Question 32, multiple choice. What percentage, all right, so 4A equals B. Now, I like drawing bars. There's my B. Now, let's draw another bar that represents the A's. Now, it says 4A equals B. So I need to split the A bar into fourths or into quarters, like that. Because then this will show me that, yeah, 4 A's equal 1 B. Now, it says there, what percentage of B is A? So what is that? Just one of them as a percentage. Well, you can see it's been split into quarters. And hopefully some of you, hawk eyes, eagle eyes, sharp brains, are thinking a quarter is equivalent to 25% or 0.25, which is 25%, which is there. Okay, so that's how I do it. Draw it nice and visual. But yeah, 4A equals B. So essentially you're doing B divided by 4. And if we said B, for example, was 1, well, 1 divided by 4 would give you 0.25, 25%. These are questions towards the very end, so it does involve that higher level of, what's the word I'm thinking of? Abstract thinking. Yeah, you really have to think outside the box for some of these questions, but it's multiple choice. So worst case scenario, have a lucky guess. Don't leave it blank. And the third and final question, which you're probably glad to be at the end of, we have question 33. Okay, 300 litres of water flow out of a pipe in 2 minutes. Find the rate at which water is flowing out of the pipe. Give your answer in litres per second. Now, the last word is crucial, that's second. So I need to convert 2 minutes into seconds. Well, we know there's 60 seconds in 1 minute. So in 2 minutes, there must be 120 seconds. Okay, now to work out litres per second, I need to do the total amount of litres divided by the total amount of seconds. Because the total divided by the number, so the grand amount divided by how long it took to create that will give me how many seconds or litres per second. So 300 divided by 120, once again, use a calculator, give me 2.5. There's going to be 2.5 litres per second. It's the same way if you wanted to work out someone's pay. If you know they were paid £480 for 40 hours, you do 480, you divide it by 40, and then you'd get your hourly rate, okay? Which in that case would be £12 an hour. So take the total, divide it by the time. Total divided by time works for pay per hour, works for, flowing rate, etc. Water out of a hose pipe in this example, but there we go. You'll see that we have arrived at the end of the PowerPoint. So I hope you found it beneficial. Anything on there that you were unsure about, there's 33 questions, there's a lot in there, isn't there? Look at all that we worked through. Anything on there you're unsure about, just drop me a message, Sam Parry on Microsoft Teams. I'll do my best to help you. I'll send you some work your way, send you century assignments, anything like that, okay? But hopefully you found it beneficial. I am going right back to the very start because I want a quick reminder that the next exams, Tuesday the 7th of June, Monday the 13th of June. 2 more weeks of solid, good revision, good preparation, and then you are done. Okay? Guys, all the best. Thanks for tuning in. And I'll see you guys in and around college soon. Okay, bye-bye.